Good afternoon and welcome to session 2 of Tile Basics. In this session, we'll be going through some of the basic test actions and data items for our profile. When you open the profile and you get started, you're presented with the flowchart area, the instrument area. We've previously worked with this profile in other sessions to lay it out this way. And then we have the palette. Now in the palette, we have all the different actions that we use to talk to the instruments and different calculations. There are actions for, monitoring, basic spectrum analyzer, older receivers. We have an action, the measure range extended, talks to, much newer receivers. And then we also have actions for immunity and susceptibility, cable calibrations, amplifier checks, reverb chambers. But what we'll focus on in this session is some of the basic actions we use in a profile to create just the radiated emissions demo that we're going to do as we work through the sessions. So when I start a new profile, one of the first things that I do is I drop a go action onto the flowchart in the upper left corner. The go has dual purpose. In basic tile, when you're just doing basic profiles, it's kind of a placeholder. It's a jump to point. It's visually easy to find with your eyes when you're looking through a busy profile. You can see where the goes are pretty easily. It also has a dual function. In intermediate and more advanced profiles, it also holds what we call the sequencer, and there will be a future session, a future more detailed session just on sequencing. It's more of an intermediate to advanced concept. But the go, I always put one in and call it main. And that's the first action I put in a profile. And we'll get into why later. And then when I'm also building a profile and putting actions in, I like every few changes I make, I like to just, reach up and hit save. That's good discipline. Sometimes we forget to do that. Some of the other actions that we use frequently, we have the autosave action, which looks like the disk here. We have the export windows. It's called save windows, but it's actually for exporting data. You can export graphs, export tables, export CSV files. Then there's various actions for lab information, operator information. We use the EUT information quite a bit. We'll be getting into that as we go through our profile and build it out. And we also have another item we use a lot is called the prompt. And this is probably one of the most versatile actions in tile. So let me grab that and we'll put it up here. I always put in go for the main and prompt. I make a main menu out of it. And the prompt can do many things. So the prompt can use logic. It's more of an intermediate feature to use logic to automatically choose a path. It can also be a jump to where you can just put all kinds of choices in here. And then when you configure this and run it, each choice is its own push button on the screen. The prompt can also be kind of a jump. If we set it to look for multiple choices, but only give it one choice, it'll jump to that location without any windows, notifications, or interference from the operator or feedback from the operator. It'll jump to that spot. So the prompt is a very useful, very versatile action. So we've got the main menu set there. The next thing that we go to is the Init. Whenever you're talking to an instrument, be it GPIB, Visa, what have you, you need to send it an initialization command. There's always a command that kind of tells it to reset and get into listen mode, to listen for the remote command and not the front panel. That's what the Init does in the flow, and it's critically important. Even though our simulated instruments don't require it, I like to put it in. It's just good discipline. As we build the profile out, it will definitely come back. The next function in the list, the next action, is called entry. It's a direct entry action. So what it does is you actually put a data item in here. You could have a limit line, you could have some kind of item, And when the entry action is run, it'll open a screen so you can modify the data. When we add limit lines later, we'll get into that in a little more detail of what the entry action can do. The next action is our math action. And what this does, this is a holder in the flow, and it allows you to put equations and formulas and various things in and select them. And as the test process flows through this action, it will run those equations. So you might take some raw data and apply antenna factors, cable losses, and have that equation get calculated in the math action. Some of the test actions have calculation tabs that function the same as the math action, but you can also do it in a standalone action. It makes finding that math easier too, because it has its own place on the flowchart. This action that looks kind of like a pencil eraser or a prism is actually the clear data action. Any data that is available that can be cleared, any raw data, any measurement data, any equations, they can all be cleared. And so they will show up available in the list, and then you can select which ones you want to clear the data from. Tile does not allow you to clear preset data. It just won't do it, which is really what's really great about a preset, using your test limits and your conditions, making them a preset type. That way they can't inadvertently be deleted or cleared out. The next action next to the clear is the transfer action. We're going to be getting into this later too. And what the transfer action does is it allows you to copy data from one data element to another, or you can pull data directly from a CSV file and place it into a data element. Two very common uses for this action are selecting different test limits. You can put the limits in, and whichever one you select, it will copy into the limit that's active, the one that's getting used into the action, so that you don't have to change the action every time you run a different test. The other common application for the file is for it to import the CSV into a data file, like antenna factors, probe factors, coupler loss factors. All of these things can just be imported from a CSV right into Tile. We'll be covering that pretty extensively as we build the profile out as well. There's actions, this action that kind of looks like a mountain with the sun over it. It's actually a photo action. You could actually put in your test flow, you could prompt the operator with a picture that would show up in that window. You could give them a message that says, hey, set the calibration jig up so it looks like this, and have the photo, high-res photo show up that shows them exactly how you want the setup to look before they hit OK and proceed with the test. Pretty useful in labs where the operator may not necessarily be a hardened EMC engineer. We have a timer. We can also do like a timer delay. So as you're running through the test flow, we could set the timer and it'll put a prompt up and give you a countdown clock. Maybe there's an operation that typically takes 8 to 10 seconds that, you need the operator to manually switch something on your EUT, something like that. You can either set a window and prompt them to do it, or you can just set a timer so that after 10 seconds, it just, continues. After the timer, we start to get into, like, here's the lab conditions, the weather, like the temperature and humidity in the lab. You can set that up, or you can import. If you've got some labs will have a weather station that actually updates a digital file. You can actually, for like an outside test site, you could actually import that weather data right into Tile if you wanted to. The I action, the I icon, the serial communication icon, don't use that a whole lot, but it can send serial commands out to other devices. And then we get into our actual test actions. When we get past that, we get into measure range extended. different different methodologies for using network analyzers, fast scans. The pre-scan action is a very popular action for emissions. You'll set up your tower and turntable, set up your the frequency range you want to test, and set up your parameters, and then you can actually run multiple detectors and just take your peak, quasi peak, and average data, and it will capture the positions of the highest readings. It's a very useful profile. We use it a lot in a lot of our canned emissions, commercial emissions profiles. Then we get down into peak discrimination profiles. Once you've determined a suspect frequency list, you can put the list into kind of a quasi peak tuning mode. Now that more and more receivers are having time domain and FFT measurement, this may be kind of getting to be a little old school, because we're getting receivers now that if you're willing to invest a couple of hours in the test, you can now take all of the quasi-peak data as a sweep as well as the peak and average data. You don't really need to stop and quasi-peak at a specific point. You can just run the sweep and then find the azimuth and elevation of the highest points. Then we get down into the actions that have outside test site, antenna calibrations. There's independent actions for a mast to move an antenna up and down, or a turntable to spin it. But I wanted to get to the visa. The visa action, we have a very comprehensive library of drivers that run a lot of equipment, but the visa action allows you to put an extra command in the flow. If you want to set a specific setting or change the turntable spinning speed, or there's any number of things you can do with the visa action. It allows an intermediate to advanced operator just to add extra commands in the flow. You could, in theory, write most of the profile with just visa actions and the raw instrument commands out of the manual, but that would defeat the purpose of having a driver. So after the visa action, we get to the read action. And what the read action does, this is an interesting one. You can set up a monitor, you can set up a signal generator, you can set up a spectrum analyzer. And I actually use this action frequently as a troubleshooting. I can put the instrument driver in here, tell the monitor to be on, how many readings to take, and just hit run. And if the instrument's working and the connection's good, it'll just put up a little window that's giving you a status of the voltage or the field or the power, whatever it is that you're measuring. You can also set a signal generator to a discrete frequency and amplitude, which really comes in handy in system verification profiles, where the standard requires you to sweep the band, sweep the ambient with just this one spike generated to make sure that you can accurately record that level. The mill standard has been doing that for decades. So those are a lot of the actions. There's many more actions we could go through, but they're more focused around GTEM calculations, field uniformity, reverberation testing, and these things are all outside of the realm of basic tile. We're going to just do a basic radiated emissions profile, and then we'll talk about immunity and susceptibility in some later sessions too. So that's the actions. Now on the data items, right now we don't have any set up, but if we've got a spec-an set up. If we're going to take data, chances are we need to create a data item. We'll call it dat spec-an. And if we go to the source tab, there's a lot of options here. It can be a measurement, it can be a file, which, much like your transfer function, you can upload a CSV file or a DAT file into the data element. It can be an equation, which we do various math. We have a lot of math functions in the manual, and we have a lot of power in the equations. Or it can be a preset. And the preset is what I talked about is earlier is you want to make your limits and your hard constants in tile, you want them to be presets. That way they can't be inadvertently deleted, inadvertently cleared. They're going to remain constant. You'll also notice in this window that there's kind of a typing to the data, that there's a continuous linear, continuous log. Now, what's interesting about that is most EMC standards, when you're graphing and you're doing your limits, the graph is on a log scale on the X scale, and it's also a log slope on the limit. But what's interesting about the data itself is the data itself, when you run a test and you compare it to the graph, each point is a discrete point being compared to the limit. So it doesn't have to be log or linear. It's just a raw measurement. It can be either one. But your limit lines, wherever there's a slope in the limit line, this needs to be log, or you run the risk of comparing things incorrectly. But also on our graphs, the limits, we'll do some auto interpolation when you set them. So we'll get into that as we build this profile out too. The other data type is this can be a word. We have ways in which we can enter, pass-fail criteria, or we can put time, timestamp. We can make a word type data item and then have the timestamp fill it with an actual time label for each data point. So there's a lot of versatility in the data. We can create many, many different things here. So before we move on to the next session, we'll wrap this up and close this out. We'll be adding data items. We'll be filling out our main menu. We'll be doing simulated instruments. All of that is upcoming in the next sessions. This concludes session 2.